we're going. Okay, so this I put in the book after I sent the book away for photocopying, but this is just a huge review. Now for some of you it has been an entire year since you've done math, okay? And math is like a language. Like if you've ever been to another country and you've even spent time there and you picked up the language, leave for 6 months and see how you do, right? It goes fast, right? I can't even understand how fast I've lost other languages when I've been to, you know, I thought I knew them, right? But you don't use them every day, so it goes, right? So if you're not remembering this stuff, you're not dumb, you're not using it, right? You don't use this stuff every day. But the whole goal, obviously, is that as we do it, you're like, oh, okay, I kind of remember that. Or maybe you're like, I've never seen that before. Well, now I've seen it, so now I get it, okay? Now, before I get into the text, or the workbook that I've given you, the notes book, I just want to go through this stuff that's not in the book. Now, the first thing is slope. Now, slope is always y2 minus y1 over x2 minus x1. What are the words that mean y2 minus y1? Rise over run. Okay? So right, when you're doing y2 minus y1, you're doing the how much it goes up and down, right? That's rise. And then you have run. Now, if you have a slope that goes up, that's a positive slope. Does anyone know the variable for slope? It's not s, because that's been taken by speed. It's the weirdest one ever. M. Yeah. Slope is m, so that's like positive m. See, it's a language, right? If you don't like positive m, what the crap? What? M? What's that? You know? Now you know m is slope. Oh, yeah, okay, right? And when anything's going down, that is negative slope. What is this? Zero slope. Yeah, no, zero and undefined get mixed up all the time. And the way that I was thinking about it, like, you know, when you hit the slopes, right, that's skiing, right? And wouldn't this be the most boring skiing ever? That's like cross-country skiing, right? No one likes cross-country skiing. But look at this one. That is a good hill right there, right? That's undefined. So zero slope, boring, right? And, well, I guess that wouldn't be much fun either. But positives always going up, negatives going down, okay? Now the slope intercept form. Now that should actually be called the slope y-intercept, but it's never called that. It's called the slope intercept, but it means slope y-intercept because in the slope y-intercept form, this is of course the slope and this is always the y-intercept. Okay, always, always, always. So this is the slope y-intercept of a line. Okay, and then slope point form is the other form that you learn. And that's when you have y1, you can put 1 point in and a slope. Hence the name slope point. So the slope would be your m and your point would be x1, y1, right? So if you take that in, you can find the equation of any line. Okay, now kind of obviously a good skill is can you look at a line and say, hey, that's the equation to that line. Now, if you look back to here, the slope y-intercept, okay, do we know the y-intercept? The y-intercept is where it goes to the y-axis. It is 1. So we know the y-intercept is 1. Now, do we know the slope? Well, first of all, you got to find 2 nice points that the line goes through. And here's a nice one, obviously. Maybe I'll do it in blue so you can see a bit better. And see, that's a nice point. Do you see how it goes right through the crosshairs? Those are considered nice points. You know, this one here, not a good point. Like, what is that? I have no idea what that is. But what is this point right here? What is that? How would you say it? Okay, we're doing a lot of review here. No, what's this coordinate called? Like x comma y. The x would be 0 and, so this is 0 comma 1, right? It's always x then y. And this one would be 3, 3, 3. Yeah. That one I guess you couldn't mix up. But you could see how the first one, right? It's those get mixed up all the time. I've been doing this a lot longer than you, and I still mix them up. Okay, sometimes I'll put 1, 0. Obviously you can see I'm going to get it wrong from that, right? So again, doesn't matter how smart you are, you're going to make those mistakes. You just want to kind of double check. Now, the other way, and I know this will bring back some memories, is you can actually just draw a triangle. Now, would this be a negative slope or positive slope? Which would be positive, because we're going up, right? How much do we rise? How many? Look, in my triangle, I'm rising 1, 2, and I am running 3. Okay, so it's up to over 3. So my, oops, that was a crappy 3. So if I'm going up and over, my slope is rise over run. Okay, so my equation would be y equals it's mx plus b. M is x plus 1, right? And I'm just going to write the equation above. Y equals mx plus b. B stands for what? Y-intercept. My y-intercept is 1. My slope is 2/3 because I have to go up to. Now I could have used y2 minus y1. See, 3 minus 1 is 2 over 3 minus 0. Now, just to show you that I didn't just make this up, because I do make a lot of things up, I won't lie. If I put this in, okay, and we want to graph it, right, we go 2/3 x plus 1. I'm going to hit zoom 6, so I'm back to the... Okay, so it shows that I got it right, okay? Now, this one, I think, if I go to my window settings, this one is basically well, -6. If I want to make it look exactly like the... my y, I'm actually putting in my window settings. So if I want this graph to have a minimum of -6, this is like -8, right? Okay, these are called my window settings, and we're going to do a lot of work with these, but then maybe this will make look a little closer to the one we just did. But there's my verification. Now, I'm going to be straightforward, upright with you guys right from the beginning. Is that diploma at the end of this semester, we're going to look at it like it's a game, okay? And I'm going to teach you every little trick to be able to get 100 on that test. And you wouldn't believe how much this calculator can do for you. And check, okay? Because here's a good example. If it just said, what's the equation of this line? And you're like, okay, I can do this. And say you got y equals, right? You're like, well, that's cool. I'm pretty sure I got it right. Hey, look, it's b. I'm happy. I'm moving on. How do you know for sure? You're going to graph it. And you're going to make sure it looks like the identical picture when you graph it, right? And you go, okay, I know I got that one right. So I'm always going to teach you how to be able to make sure you got it right. I have given many, 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 many diplomas, and I always have. Like one diploma, I had 30 students write it, and 6 got 100 on it. And I just teach them how to play the game. Teach them how to play the game. That was one class. All that year, all of Rochette got 6. Okay? It's not because I'm like some genius and I know the tricks, right? And I'm just going to give you because it's a game. Okay? This is all a game that you guys need to get the best mark you possibly can. I'm going to show you how. And it's not like because you can do this, you're cheating. No, it's actually another level of learning that you can actually use the technology. You got to take this in with you. You might as well use it, right? So I would highly recommend please get a hold of one of these calculators. Okay, the TI-83 Plus is all that you need. The 84, but the 83 Plus, there's just tons of them on Kijiji. Like kids are using them as like doorstops and stuff. They're like, get rid of this thing. I'll sell it for $5 or $10, right? Get one. If you haven't been using one, like I get my grade 10s to get them, so by the time they're in grade 12, like they can do anything with that calculator. But technology is a big part of math, okay? It's just not, let's just do some number stuff. We've got to be able to learn how to use the technology to verify this stuff. And again, I'm going to try to, depending on the question, I'm going to show you some really cool things to be able to make sure you got it right, okay? Now, B, what is the y-intercept? Okay, so we're back to b equals 1. See, now I can put b equals 1 and hopefully you know what I'm talking about. No, right here, right? And again, if you're like, what? I forget what b is. Like, write this for yourself, quick. Oh yeah, y-int. That's what b equals, okay? Now, see, that's a good point. And I like this one down here too. Do you see that one? Okay, and then I'm going to draw my triangle in. And I always go up or down and then right. So I went down 3. So if I go down, I always put -3. If I go up, I will put positive. So you always go up or down and then right. You never go left. Up or down, then right. Okay? And I'm going to go down 3 and right 1. So my slope is rise over run. So my equation is y equals -3x plus 1. Again, I could put it in the calculator and show you, but I think I've exhausted that to death. Okay, now C, we have to get into y equals mx plus b2. Okay, now first of all, you have to be able to make sure you isolate the y, because it's got to be y equals, right? But right now you have 2y. So I'm not going to mess with it right now, but I need to get this out of here. Like, I got to get that out of there. How do you get rid of that 3x? You minus 3x, right? We don't want to divide 3x. That would not be good. Because if I divide it by 3x, then I got to take this and divide by 3x, and I can't do that. So we're going to minus 3x to both sides. And I'm going to go 2y equals -3x plus 6. Now, why didn't I just go 6 minus 3x? Why am I trying to make this confusing? Because I know what form I want, don't I? I want mx plus b, so let's put the x first, because I know where I'm going. Okay? If any of you play chess, right, you always got to be thinking 3 moves ahead all the time in chess. Right? If you're thinking 1 move ahead, you'll always lose. You got to be thinking, what do I want this thing to look like? Oh yeah, mx plus b. I must put the x right after the equal sign, right? Now, how many y's do I want? 1. So if I divided this by 2 and these by 2, actually I don't need to put a long line there. So y would equal -3 over 2x plus 3. Okay. Okay, C should be an insult to your intelligence. What would this equation be? It's not a good setup, eh? You get it wrong, you're like, oh crap. Y equals x plus 4. This is the English is the top and the bottom is in math. Math is confusing because of its efficiency. Like, this means these two are identical. Has a slope of 3 and a y-intercept of 4. Y equals 3x plus 4. Right? Y equals mx plus b. B is 4, m is 3. Okay, has a slope of 2 and goes through 3, -1. Now, don't get this mixed up with, it doesn't say that's the y-intercept, does it? It goes through that point. So if they give me a slope and a point, what should I use? Slope point formula. Whoa. Okay. Slipped. Okay, right here. The slope point form. They give me 1 point, my x and my y1, and they give me the slope. So let's write it down first. I got y minus y1 equals mx minus x1. Okay, now I do this every time or else I get it wrong. Okay? Like I have to tell you, I was not one of those students that was strong at math. Okay? And people are always like, hey, do you love math? Do you love math? I don't love math. I love teaching math, but I don't love math. Okay? I was the kind of student that if I didn't study, I failed. Every time. But if I worked hard, I could beat people in my class that were way smarter than me. Okay? And I know they were smarter because they didn't have to study. They didn't have... some people, they don't have to study, they get 80. I'm not that guy. I do not study, I fail. It's like clockwork. Okay? Everything that I show you, I've had to put into place for myself to be successful. Okay? I had a student last year, this is a true story. I have in my career, I have never had a student weaker than this student. She would struggle in a -3 class, and she was in -1. But I've never had a student work so hard in my life. She never got, I know she didn't pass one quiz the whole year. Okay? I don't know how many she got right, but she was in my room every morning, every lunch. She rewrote every quiz throughout the entire year. She had tutors going. I mean, it was crazy. I mean, when it was diploma time, she was taking diploma prep. She took it like 3 times. She had tutors. And because she worked so hard, okay, she got 54 in my class mark, and this is still when it was worth 50%. And she got 46 on the diploma, right? Still got 50 in the course. But if you could meet this person, right? Hardest working person who she struggled in all school, everything. She struggled in swimming lessons. She struggled in everything. But she worked so hard, she just made up for it. And I can guarantee you that none of you are even close to her abilities. But so I guarantee you, if you work hard, I guarantee it, okay, you will do very, very well. And it just goes to show, like, if you aren't going to give up, if you're going to work hard, right? Because like I grew up without any money, and we were poor, the whole thing. My only ticket was education, and just out of sheer luck, out of people always looking out for me and pushing me, and you know, the odd thing happening that someone was looking at my stuff and saying, no, you shouldn't be taking these courses. Like when I picked all my courses for grade 10, I picked all the lowest, easiest courses I could. And the principal of that school said, no. I'm like, what do you mean no? He's like, no, you're not taking these. You're taking these. I'm like, what? You can't do that. I'm not even letting you get into these courses, right? And changed my life, right? From there on, and I look back and I'm like, if that principal would have said, yeah, that's what he wants, let him have it, right? So, you know, and that's what I said. Like, I got to do that for my students. I have to advocate for them because, you know, when you're in high school, you really don't know. You don't know what you don't know, and you really don't know what's out there yet. But you certainly don't want to live with regret all the time going, like, why? Why did I do that? Why did I give up? Why did I, you know? Because the only person that can let you down is you, okay? Don't blame other people. Don't say, oh, when I go home, my parents say I'm worthless or whatever, so I just quit. Okay, don't blame them, okay? You have to blame yourself because you don't have to believe that. And, you know, it's not true, obviously. So you have the power to do whatever you want in here, and that 100%, you just wait, okay?
Good afternoon, staff and students. Just a quick announcement before we move into our evening.
So we're back. See, according to the people out there, they didn't even know we took a break. Okay, so when I have a slope of 2 and I go through these points, now this is x1, y1. Now trust me, if I don't do that, I mix them up, because look where x is. It's first, isn't it? But y comes first over here. So we accidentally sometimes will put this here and here. Okay, happens to all of us. Okay, on tomorrow's quiz, someone will do that. Okay, is it going to be you? So now we're going to put in y minus, what's y1? Negative 1. We got that problem going on there with the two negatives. And then I've got a 2, and that's going to be x minus 3. Now what do I do with this? What's a negative times a negative? Positive. Good. So y plus 1 equals, now this is the next thing. I got a number in front of brackets, so I'm going to have to multiply both of these in. And that is 2x minus 6. Okay, and then the last thing we need to do is I got to get y all by itself. Okay, and to do that, I just need to subtract 1. So that will be y equals 2x. What would be there? Negative 7. Very good. Okay? I won't tell you my negative positive cowboy story right now, but I will later. Okay? Now, how am I supposed to do the next one? Because can I use the slope point formula? Can I find slope? I can, right? Because this is x1, y1, and this is x2, y2. So my slope formula is, right, m equals, it's, well, let's write down the formula, right? y2 minus y1 over x2 minus x1. So, and that's why I need to do this. I get them wrong all the time if I don't label first, because now I can see what y2 is, right? So that's just going to be 9 minus 3 over x2 is 7 minus 5. Okay, so 9 minus 3 is 6. 7 minus 5 is 2, so my slope is 3. Now, do I have a slope and a point? I have a slope. Which point should I use? Five, 3? Or could I use 7, 9? Doesn't matter. It's any point on that line. Are these points on this line? Definitely, yeah. Is this the slope of this line? So it doesn't matter. You actually get the same answer, believe it or not. Okay? Some of you guys are like, I don't believe you. Okay, well, let's try it. Okay, so it's, what's the formula? It's y minus y1 equals mx minus x1. Okay, so let's use 5, 3. So y minus 3 equals, so I'm going to use 5, 3. Let's just write that there. Oops. So we're like, where did you get that from? Because 5 comma 3 is definitely one of them. So y minus 3 equals m is 3.
Mr. McBurney, can you call extension
X
303, please? Mr. McBurney, thank you.
Minus 5. So that would be y minus 3 equals 3x minus 15. Then I will add 3, y equals 3x minus 12. Now, I always have students who go, like, if you use the other point, though, you won't get it right. I'm getting it wrong. Okay? And I'm like, well, let's see. Okay, so let's use 7, 9. Okay, so that's y minus 9 equals, slope is 3, x minus 7. So y minus 9 equals 3x minus 21. Okay, I will now, what do I do to get rid of that minus 9? I'll add 9, correct? Y will equal 3x. What's negative 21 plus 9? Negative 12. That's good proof that it is the same line. Doesn't matter which point you pick. Okay? Is this bringing back some memories? No? Okay. Well, in case you were getting it, let's try and confuse you a bit more here then. Okay, does anyone remember this? Y equals a x minus h squared plus k. Yeah, remember running into it in a dark alley or something? That is your parabola. Your horseshoe, right? The vertex is hk. It's right down there. hk. The axis of symmetry is this thing. Okay, so there's vertex. Axis of symmetry is if you were to cut it in half, which is always your h. You see how our study sheet's going to come in handy if you can start getting all this stuff down? Because we're learning a lot of stuff. Now, if a is less than 0, there should be an a here. Yours has it, right? If a is less than 0, what's another way of saying less than 0? What's the word for less than 0? Someone said it. It's negative. That's what less than 0 means. If a is less than 0, it will always be going down. And if a is positive, a is that number in the very front, then it's going up. Okay? Now, you can also take the same thing and you can factor it like this. So it's a, x minus m, x minus n. And m and n are your x-intercepts. So when you go like this will be m, and this will be n. And if you want to find the axis of symmetry, which is the h, we already talked about that, but I don't have an h. Do you see an h? I don't have an h. But if you take m plus n, and then divide by 2, it'll give you the average, or the middle, right? If you have two things, add them together, divide by 2, you'll find the average, you'll find the middle. Okay, and again, if a is less than 0, aka negative, it's going down. And if a is greater than 0, positive, it's going up. Okay. Now, let's look at these here. I see a couple of people writing yet, so I don't want to go. Now, this is called the vertex, HK. This is the vertex right here. Oh, that's the vertex. What do you think that point is? Always say the x first. 3, comma 2, right? That's 3 down there. Okay? Now, is this thing positive or negative a? Ah, nice. Negative. Why? It's down, right? Negative's always down. So it's a negative a. Axis of symmetry. So let's write this down. Sorry, we got vertex. 3, 2. Now we say that it has if it's going down, we say this is a max at, and we always say the y value. What is the y value? At 2. So it's a max at 2. That means that's the highest y value on that entire chart. Because height is always done by your y, right? Okay, and we say that it's opening down. We already talked about that. Why? Because there's a negative a. Axis of symmetry is what? And it's always x equals. What is the x value? 3. Right? It cuts it perfectly in the half. Opening down. Oh yeah, I must warn you, I have terrible writing. That's probably why you'll have to watch the videos over to actually figure out what I'm writing down. Okay, axis of symmetry, x equals 3. What are the x-intercepts? 2 and 4. Okay? Does that make sense? Again, I'm just kind of going through all the words right now. Now, this is y equals a x minus h squared plus k. That's the form that it's following. Now, this is what's kind of weird though. The formula has a minus in it here, but the equation they give me is a plus. So that's like weird right away. And then the formula has a plus in it, but this one has a minus up here. So the first thing we want to do is we want to make this fit in here perfectly. So y equals, the 4 is going to be the 4, okay? And then I'm going to go x minus, well, what can h be? Should I put a 1 there? Negative 1. Do you see? I've served two masters here. Master number 1 is I cannot change the question. Is minus negative 1 the same thing as plus 1? But I've made it look like this. So what is h now? Negative 1. Do you see that? Okay, and let's finish up. And then I have to make it plus. Because see how there's a plus? Like I got to keep the forms the same. What would I put for k then? Because I can't change the question, but I need a plus sign there. What should I put? Or just put a negative 3 there, right? Plus negative 3. Do you see how I've served two masters? I have made it look like the formula, and I haven't changed the question. Because if you change the question, there's a pretty good chance you're going to get it wrong, right? So now, hk is negative 1, negative 3. That is my vertex. Now, is this thing going up or down? Why? How do you know it's up? It doesn't say anywhere that it's up. Ah, it's positive 4. It must be going up. Okay, so I can start thinking here. Vertex, negative 1, negative 3. Negative 1's here, negative 3's like here, so it's like this. So it's going to look something like this. Okay, and we're not going to get into more detail at this point on this. How about C, going up or down? Yeah, this is going down. It always says if that A is less than 0, it's going down. Now this one doesn't give me my vertex nice, does it? This form gives me what really good? What does this form give me? The x-intercepts. What are they? Now I want to write this. This is A, x minus m, x minus n. That's the formula. So we look at the number after the minus sign in the first one. So what is m? It's 1, isn't it? Now what's wrong with that second one though? Like my formula has a minus n in it, but there's a plus in there. So what am I supposed to do with x plus 3? So it looks like the formula, but I can't change the question. X minus plus 3. Very good. So I've put x minus positive 3. Or no, that wouldn't be right, would it? Because now what does this equal? Negative. So I've changed my question. So I can't do that. Wouldn't it have to be x minus negative 3? Because I've put it in the right form, but I haven't changed the question. Okay, so what is n? Negative 3. So my two intercepts are at, so at 1 and negative 3. And I know it's going down, so it's going to look something like this. Oops, that was horrible. So it's something like that, right? Again, I don't want to get into too much more detail about that stuff. Yep. See, it's the number right after the minus sign here. If you look at it, it's got to be x minus m. So m and n will always be your x-intercepts. So 1, the number that's right after the minus sign, and the number that's right after this minus sign. So that's why I get my 1 and my negative 3. Okay? The first class of math after a year, it's right, it's a lot, right? But trust me, you'll get this stuff. Okay, so now we're into your books. 5.1. We're going to have that thing worn out before you leave here.
Mr. Convente, can you call extension 303? Thank you.
Okay, so 5.1. So we got to go all the way to 5. So we're doing polynomials. The polynomials. Do I have numbers in the book? Probably not, hey? So 5.1, polynomials, starting in the middle of the book. I got to mess with you. I don't want to start at the beginning. Everybody starts at the beginning. That's boring. You guys ever watch Pulp Fiction? You ever seen that movie? It starts in the middle of the movie, and then it loops, and it comes back to the middle again. It's the first movie that ever did that. Okay. We're going to be talking about polynomial graphs. Now, if you're going to be talking about polynomial graphs, it's kind of good to know what a polynomial is. Okay? And it's been a while, so some of you guys probably, I think I've heard the word polynomial before, but I'm not quite sure. Now, a polynomial, okay, it is a function with only, underline that 2 times, whole number exponents on the variables. So a polynomial function is a function with only whole number exponents on the variables. So example, f of x equals 5x squared minus 3x plus 7. Okay, what are whole numbers? It's a good question, eh? Yeah. What are natural numbers? Okay, cannot be 0 or negatives. When you first learn how to count, you will start with natural numbers. Okay? You don't take a kid that's learning how to count and teach him what 0 is. Right? You will mess him up bad. Right? But when you know what one thing is, take it away and he'll learn what 0 is very quick. Okay? So your whole numbers are always going to be 0, 1, 2, 3, dot, dot, dot. Okay? Now this would be called a polynomial degree 2. Why is it degree 2? Because of this 2 right here. The largest exponent names it. You wouldn't call that degree 1, but you're like, look, that's degree 1. That's what degree 1 means. Degree means the exponent. Doesn't matter. The biggest names it. Okay? Now you could have this. H of x is 3x plus 9. What degree is that polynomial? What's the biggest exponent? A 1. It's degree 1. Okay. So that's just what a polynomial is. We're just going to be doing 5x cubed and all that stuff. Now, remember when we do our quadrants? This is called quadrant 1. This is the, whoa, I'm not having good, okay. That's quadrant 1. Yeah, oh. No, it's good. Yeah, those are just examples. Sorry, I'm just looking at my clock here. I'm like, this. Now, remember our graphs? We have degree 1. This will always be degree 2. Or quadrant 2. This is quadrant 3. We use Roman numerals for these. And this is quadrant 4. Okay, so this is 1, 2, 3, and 4. Again, just review. So we got to get good at it. We're like, okay, it starts in quadrant 1, ends in quadrant 3. Okay, you got to be like, oh crap, where's 3? Okay, so remember, this is the first quadrant you ever learn how to start graphing. You don't do negative graphs and stuff. You learn here, and then it goes counterclockwise, right? Now, y equals 5. How do you graph y equals 5? Now, what is the degree of this? What is the degree of that polynomial? Where is there a 1? Okay, it is on the variable. Is there any variable? There actually is one. It's invisible, because if you put x to the 0, what does x to the 0 equal? 1, right? So this is actually degree 0. If there is no variable, it's degree 0. Because anything to the 0 power equals 1. Okay? So 5 times 1 is 5. So there's actually a 0 there. So when you graph y equals 5, it's going to look just like that. That's supposed to be a straight line. Okay? How many zeros are there? Does anyone know what a 0 is? Very good. It's the same thing as x int. Okay? These two mean the same thing. There are none. And the number of y-intercepts, there's 1. Okay? And just draw an arrow there. There's your y-intercept. Okay? There's a lot of things that are going to come back to you now, because we're going to talk about looking at that graph. I know we're kind of switching pages, but describe the end behavior. Now this is the weird things. You have to say the line extends from quadrant 2 to quadrant 1. Okay, we always go left to right, just like you read. Okay, so it goes from quadrant 1 to quadrant 2. What is the domain of that line? What x values are on that line? Okay, we'll just draw it quick so we don't have to keep going back and looking. So that was 5. What's the domain? What x values are on that graph? You guys remember how to do domain and range? What x values are on here? Well, every x value is going to be on here, right? Because it goes forever in both directions. So x is in the reals. Remember that? What y values are on this graph? Are all the y's on this graph? No, just y equals 5. That is the range. That's the only y value on that whole graph. But no matter where you go, this would be like 3, 5, right? This might be like 6, 5. And do you know there's like a billion points in between 3, 5 and 6, 5, right? And that just goes forever. But 5 will always be the y. How many turning points? Okay, none. Okay, so yeah, exactly. So turning points is like when it goes like this. So it actually turns, right? So this would have what we call, because you got to go up, right? So you actually, this would be easier to show. This is where it turns, and this is where it turns. This would have 2 turning points. Just like if you were driving, where did you actually turn? Okay, our graph that we just did, no turning. Okay, so that is called I didn't even talk about that. That is called a constant function. It's just a number. Y equals 3. Y equals 7. Y equals 21. That's just a constant function. That's what that is. And it'll always be a horizontal line, right? Now we've done these quite a bit. Linear functions. Okay? Now a linear function makes what shape? A line. So does a constant, but a linear is a little bit more Well, a lot of, well, they're just as linear, but this one has some, like, what's this thing? That is the y-intercept. Very good. This is the, what letter is that? B, yes. So that's y-int. You may remember that from half hour ago. There we go. So we got our y-int. What is the 3? The slope. But you know how we all hate fractions? Everybody hates fractions. You can admit it. It's okay, right? Fractions are way better when it comes to slope because the slope of 3. Like if I'm right there, how do I like go 3? What does that mean? So make it, what is 3 in fraction? 3 over 8? What is 3? 3 over 1. What does that mean? That means go up 3 and right 1. So we go 1, 2, 3. We go up 3 and right 1. Now if that would have been a negative 3, what should I have done? Down 3 and right 1. When do you go left? Never. Always go up, right, or down right. Okay? You never go left. Okay? So 3 over 1 means up 3, right 1. If it was negative 5 over 2, you go down 5, right 1. You never go left, okay? So you use your negative or positive to decide if you're going to go up or down, and then go right. Does that make sense? Okay? So now that I have 2 points, which is all you need to draw a line, that is my line right there. Number of zeros, how many? What are zeros? X-ints, how many? There's 1. How many y-ints? Okay, now the end behavior. So where does it start? Which quadrant? Third quadrant and goes to the first. So 3, 2, 1. See, it's just getting the language back, right? Like that's all we're doing is trying to get all the language back. Okay, what's the domain of this? It's on the next page, but we can look at it. What's the domain? Remember these? What x values are on that graph? Yeah, all of them, right? So domain, x is in the reals, right? Yeah. And how about range? Y is in the reals too. How many turning points? So no turning points. So today's all about just getting all this stuff back. Okay, and then like I said, all of this stuff is here, but we're not going to do it there. We did it on the other page. Quadratic functions, x squared plus 4. What's the degree? Degree 2. Okay, circle it. That is where I got my 2 from. Now, using your graphing calculator, we don't have to get our graphing calculators. I'll just, okay, it's going to go through 4. It looks like this. Okay, just draw that. For this one, number of zeros. None. Number of y-intercepts. 1. End behavior, where does it start? So quadrant 2, 2, 1. Because here's 2 and here's 1. Domain. Yeah, x is in the reals, good. How about the range? Y is greater or equal to 4. See, it's all the 4 and up. Number of turning points. Come on, if you're driving a car, how many times have you turned? Once, yeah. Okay, cubic functions. 5x to the 3, what's the degree? Okay, Now we're going to sketch, I'm just going to, this one goes right through here, and it goes like this. It goes like that. Number of zeros. How many? 1. Number of y-intercepts. 1. Okay, describe the end behavior. It starts where? 3, and it's going to 1. Because here's 3, and here's 1. Domain. X in the, now it may not look like it, right? But that thing, it is going forever just a little bit. So that would be your X in the reals, and your range, Y's in the reals. Now this one is a little bit tricky, but how many turning points? It's actually 0. Because you don't really turn. Do you see how you keep going? This would be, and they can do this, this would be 2. Because you actually have to turn. Do you see you have to turn directions? Did you really turn and change directions? This one you do. You actually have to turn. You start going back. And then you start going, right? So, tricky. And this is actually considered a local max. And this would be called a local min, where you can't really, like, what would be the maximum minimum? It just kind of does a little squiggle more than anything, right? It doesn't actually turn around. Okay? So, now this may look bad, but it's not. So workbook, page 114 to 115, and page 117. Now these are quick. These will probably take you 5 minutes apiece. Right? The really good stuff. Now, do I have all the answers on the interweb if you need it? Yes. Okay, so look through it. The answers are in the back. But check this stuff over. Tomorrow's going to be our first quiz. Every single day you'll walk in, and there'll be a quiz waiting for you. Just like a little puppy. Right? Just happy to see you. Right? At the door, grab the quiz, have a seat, write your name on it, and work through it. And if you get done, just chill. Right? I'm going to walk around. I never use quizzes as a punishment, I swear to you. So if I'm walking around and I see you've done something wrong, I'm going to help you out. Right? I want you to be successful. So super long day today, I get it, because we had to listen to all those rules, and then now we had to do all these notes. But after this, it like slows back down. This is like the worst day ever. Okay, so the other days from now on is, you know, here it is. Okay, now you have time to finish. You're going to finish your class. You're going to get your 6. And then you're good. What's that? Oh, I'm still taping. You're supposed to tell me. So I always need you to make sure I'm always taping and stop taping.